Okay, 4.3 is an introduction to polynomials. Polynomials, poly means many, so it means it has like many terms. Okay? Polynomial it could be one term, two terms, three terms. If it's just like one term like this, that's one term. It's a monomial. Mono is one. Okay? What do you think two terms would be?
3x squared y cubed.
If you have two terms, what's it called when you have two of something? Bi. Binomial. Okay, that's two. Okay, how about a three term? Let's add another term on there. That's got three terms. Try. And they don't have a 4. They just stop at 3, and then from there on you're just polynomial. All these are actually polynomials also, but after that you don't have specific names for them, okay? Okay, let's say you have a like this polynomial right here, this trinomial. Let's evaluate that for x equals 2. That sounds like something you've been doing before, right? So you're just going to plug the number 2 in everywhere there's an x. The best way to keep from forgetting part of it is to go ahead and write the whole thing down. Oops, instead of your x, you're going to write parentheses. Instead of squared, you can put the squared, or you can go ahead and write it out because you know you're going to be multiplying it 2 times, and then just stick your 2's in there. That way you don't forget to bring part of your polynomial down. So 3 times 2 times 2, 4 times 3 is 12, or 6 times 2, that's 12. 5 times 2 is 10, and then plus 10. So that's just 32. You just evaluated it. You just plug the number in. Okay? That part's going to be fun, huh? It's not going to be too bad. Okay. Each one of these, if it said to identify the terms of a polynomial, that would be just saying 3x and 5x. If there's a minus in there, if you have like 3x to the 5th minus 5x to the 4th plus 3x to the 3rd minus 2x. The terms would be 3x to the 5th, negative 5x to the 4th, 3x to the 3rd, and negative 2x. These are each a term. Okay? Just take the plus minus out and make that a term. But you keep the negative and positive with each term. Okay. See how I put the exponents going down? Every time I put exponents, I put them like a square term and an x term and then no x. That's called descending order. When you're putting your terms in descending order, that means you go down on your exponents. Okay? So always write your answers in descending order, and everybody's will match. Otherwise, this could be written a lot of different ways, okay? And a degree of a term, the degree of this term is 5. This is the degree. The degree of this term is 4. You see where the degree's coming from? The degree of this term is 3. So where is the degree coming from? From the exponent, right. Let's put one on here that has one without an x also. Okay, this one would be a 1. If you don't have an x, if there's no variable at all, that degree of that term will be 0. Okay, this is the degree of the term. The degree of the polynomial is your biggest one, the highest degree. So this is the degree of the term. The degree of this polynomial, the degree of the polynomial will be what?
13.
5. It's the biggest one. You don't add them up. It's just the biggest one, 5. Okay, the number in the front is called the coefficient. Okay, so if it wanted the coefficient of each term, okay, we're going to do that from the same one right here. The coefficient of this term is 3. The coefficient of this term is what?
5. Negative 5.
Negative 5. The coefficient is the number in the front of the variable. The coefficient of this term,
3.
of this term,
Negative 2.
and this term.
10.
Yeah. So the coefficient is the number in the front. Okay. If you have mixed up bunch of polynomials, let's get one. If it tells you to collect like terms, let's put like 5x to the 5th plus 2x squared minus 3x to the 5th plus 8. Okay, the like terms will be the ones that have the same exponents. The variables are the same exactly. So these two are like terms. Okay, so you're going to collect this and this. A 3 minus 3 is 0. So you don't even write that term. You don't put 0x to the 5th. If you do, you're going to drop it later, okay? You don't even have to write it. The x squared and this term are not alike. This doesn't have an x. So collecting like terms on this, you're just going to end up with the two that are left. Let's do one that has more of a mixture. 2x to the 6th plus 4x to the 4th plus 12x to the 6th minus 3x3 plus 2x to the 4th plus 10. Okay, first of all, let's go ahead and, when we're collecting like terms, so we don't have to rearrange them into descending order, let's just start with the biggest ones. Let's start with the x to the 6th, the highest ones. So we got 2 plus 12, 14x to the 6th. Now is there any x to the 5s? No. So we'll do the x to the 4s next. Plus 4 plus 2 is plus 6, x to the 4th. And the next lowest one? term, so just negative 3 x to the third, and then plus 10. And you already have it in descending order. You don't have to rewrite it. Okay, the missing term, if you were going to write this, which exponents do we not have in this right here? If it gave you this right here, and it said to find all the missing terms.
Something to the 2, something to the second,
Yeah.
and a 1.
The x to the fifth term is missing.
Oh,
The x to the second is missing.
1.
The x to the 1, or just the x term, is missing. It has a 0, so that one's not missing. So the missing terms would be the ones that are not there. And if it wants you to write, let me give you another one that has something like this where we find the missing terms. Let's see, if we were going to write this, let's do another one of these, and we're going to write it like this, and we're going to write it with the missing terms. If you write it with the missing terms, this written with the missing terms, you would put 0 of that term. Okay? You would put every single exponent in there. 6x to the 4 minus 3x to the 3 plus 0x squared plus 0x and then plus 10. This would be writing it with the missing terms in it, okay? You write 0 of all of them. Okay, we identify the terms. How about identifying like terms? If it just says identify the like terms, you just have to say which ones are alike, okay? You don't even have to add them. You're just identifying the like terms. I think that's about all of 4.3. You're going to be doing a lot of collecting like terms in there. 4.4, you're adding and subtracting polynomials. Okay, if you're adding polynomials, it'll be like if you have negative 6x plus 2 plus x squared plus 1/2 x minus 3. That's actually number 3. Okay, there's really no reason for them to give this with parentheses, but they do. You could just drop the parentheses and collect your like terms. Okay? So start with your highest exponent. So just x squared. The next exponent will be your x term, right? So these two right here, we're going to add negative 6 and a positive 1/2. That means you need to subtract them, right? Because you're adding a negative and a positive. Take the sign of the larger, and you'll subtract. 6 minus 1/2 is what? 5.5. And then you're going to add the numbered part. Negative 2 and a positive 3. I mean, sorry, positive 2, negative 3.
Minus 1.
Minus 1. And you already have it in descending order. Okay? This part on the answers are going to show as improper fractions. They're going to have this as 10, 11 halves. This is how the answer will show in the book. So if you have a mixed number, go ahead and do it as an improper fraction. Okay? If it's a decimal, that's okay. Just leave it decimal. Because down, you'll have fractions, you'll have decimals. But on the fraction part, leave it improper for this. Okay, let's do one with fractions. Well, that one does have fractions. Let's do one with all fractions. Like, oh, you don't have to do 13 or 14, do you? Yeah. You don't do any of the decimal ones? Okay. Let's just do another one of these then. Let's do x to the third plus x squared plus 2x to the third power minus 5x squared. Parentheses you don't really need. Which one do you want to do first?
X to the third power.
To the third. So what's your coefficient? That would be the number in front. 2 plus 1 is 3. Coefficient's 3. Okay, the x squared. What's the coefficient going to be? Negative 5, positive 1? Negative 4. So you're going to have to get really good with your negative and positives, because you're going to keep using them over and over and over. Okay, there's some problems with the negative in front of the parentheses. Okay? Remember, if you had like minus and negative, you turned it to plus and positive? Okay. All this is going to be is a positive 2x. Okay? If you have it in front of something that has two terms in it, it's going to change the sign of both. Everything inside the parentheses will change signs. Okay? So your x squared is now negative. Negative 5x is now positive. So what you're doing, let me rewrite this. What you're doing is you're changing it to adding the opposite of both of these. See? Negative x squared and a positive 5x. And the reason you're doing these is because you're going to be subtracting polynomials right after this. You're going to have to know if you have negative 12x to the fourth minus 3x to the third plus 3. You're going to have to know that you're going to be adding the opposite of all of these. Okay? So if you change the sign, your answer will be right there. If you change the sign of all these. Does that make sense at all? Yeah? Let's do a subtraction one where we change the inside like that. Okay. For subtracting polynomials. Okay, you do 33 and 34. I'll do 35. Negative 6x plus 2 minus x squared plus x minus 3. Okay, these parentheses don't really need to be here. These parentheses, you need to change the sign in there. We're changing this to plus the opposite, opposite, opposite. Everything gets changed to the opposite. That way you don't forget that you're subtracting this, subtracting that like that. Okay, so we're going to start with our biggest exponent. So we'll start out with negative x squared. There's nothing to combine it with, so just negative x squared. Then we're going with our next exponent, which is x. We need to add the coefficients. So we have a negative 6 and a negative 1 is what? Negative 7. And then we add the numbers. The 3 and the 2. The They're both positive, so just plus 5. We've already got descending order. So these aren't too bad, are they? They're kind of fun, I think, really. Kind of fun to change. Okay, they also have these problems written like on top of each other. Like you're doing 47 and 48. I'll do number 49. They also have them written on top of each other like this. Minus 9x squared minus negative 6x to the 4th. And they put them under the term that is just like it. The like terms. They line them up where all the like terms, so you could add them up like that. Okay, even on this one, before you do it, change this to adding the opposite so you won't mess up. Because otherwise you're going to look at this and you're going to say, oh, that's 0, so it'll cancel out. But this actually is not going to cancel out. So change it to adding the opposite, the opposite, the opposite, and the opposite. Change all the signs. And then all you have to do is add them. You don't have to remember you're subtracting. So 5 plus 6, 11x to the 4th. 6 plus 6, 12x to the 3rd. There's nothing to add that to, so just bring it down. Plus a negative, just put minus. Don't put plus negative. Just put minus 8x. And a negative 9, just put minus 9. You don't need to put plus negatives in there. Okay, so that's the answer to 49. Okay, you're going to do 53 and 54. Remember, these are perimeters. Okay, we have this big thing on 53. It goes up, over, down, over, down, over, down, over. You have all these numbers. How do you find the perimeter? Add up all the sides. So you're going to add all these up. Okay? So what you got to do is pick out all the ones that have A's. And add all those up. And remember, you're going to do that as an improper fraction because there's going to be an extra half here. So you're going to have 3, 4, 5, 6, 7, 8.5. You're going to change 8.5a into an improper fraction. And then these two, you'll just add. The 5 and the 7 will be off to the end. How do you turn this to improper? 16 plus 1, 17a, right? And 5 plus 7, you have plus 12. So that's the perimeter of 53. So I'm going to let you do 54 on your own. You just have to add all the outsides up, okay?
You missed some of it.
I missed some of it?
Yeah, it's supposed to be 23 over 2.
23 over 2, okay. 3, 4, 5, 6, 7, 8.
The top A is supposed to be 4A.
Oh, okay. So 8. That'd be 11 and a half then, right? That's 3 more than what I had. 2 times 11 is 22, plus 1 is 23. 23 over 2a. Sorry. Thank you, Joanne.
If I didn't have the answer.
You wouldn't have noticed. Oops. I have the answer stared at me too, but I still didn't notice. Okay. 54, you're going to be able to do simple. 55, the area of the rectangles. Remember to find area. What do you do to find area? Area is the length. Well, this is usually the length. It really doesn't matter. You're going to do this times this, right? The area is the length times the width. So you're going to do the area in each one of those, and then you're going to add it all up. Do we want to do that together?
Mm-hmm.
We do?
Mm-hmm.
Of course, okay.
Of course.
There's a rectangle, rectangle, or square, square, rectangle. Okay, this one we have 3x and an x there. So what's the area of this one?
3x.
3x times x, so it's 3x squared. This is x by x, so it's
X squared.
x squared. xx, this one is x squared, right? This one is 4 by x. So what's the area of this? 4x, right? So these are all like terms, aren't they? 3x, 1x, 1x is 3, 4, 5x squared plus 4x. It looked all hard, huh? It looked complicated. Okay, the area of a circle is what? You remember?
Circumference times your
Not the circumference, the
Median.
area.
radius times
Yeah.
pi of 3.14.
Pi r squared. Kind of like pi r squared. No, it's not. It's round. A circle, pi r squared, you get it? Pi r not square, it's round. Okay, the pi is around. Okay, pi r squared is the area. That means 3.14 times that. We're not going to actually convert this to 3.14. We're going to leave the pi in there. So the area of this one is pi r squared. There's no number for r. The area of this one that has a 3 will be pi 3 squared, right? Because the 3 is your radius, so the radius is squared, so 3 is squared. The area of this one will be pi 2 squared. So we have pi r squared plus, we need to simplify that. What is 3 squared? 9. So this is 9 pi. 9 times pi. We always put the number in front of a variable or symbol thing. Plus 2 squared? 4 pi. So we have pi r squared plus 9 pi plus 4 pi. So we have pi r squared plus
13 pi.
13 pi. That's all you have to do for that. So aren't you glad you're going to have all this homework? You're glad you're here and watching this? Okay, and that's pretty much all you have to do there. The mid-chapter reviews there, you may want to do it while you have some extra time on the spring break. The mid-chapter reviews, if you want to go ahead and do that while it's fresh in your mind. Remember, that's going to be extra credit for the test. If you would like, I could go over some of the rest of it if you want to get ahead. Do you want to go over the next 2 sections or no?
No.
No? Okay. And no questions over this one?